Even though there is nothing inherently wrong with a view model performing network requests, it isn't an approach I recommend. Moving the networking logic out of the view model has a number of benefits. It reduces code duplication, facilitates unit testing, and improves the maintainability of the project, to name a few. To build a testable networking layer, we embrace protocol-oriented programming, or POP. How that works and why it improves the testability of the networking layer becomes clear later. Create a group with name protocols in the networking group and add a Swift file with name API-service.swift. Define a protocol with name API service. The API service protocol defines an interface objects can use to communicate with the mock API. Because we use a reactive approach, add an import statement for the combined framework at the top. We define a method to fetch the list of episodes from the mock API. The method, episodes, returns a publisher. The output type of the publisher is array of episode object, and the failure type is API error. You may be wondering why we declare episodes as an instance method instead of a computed property. That is a valid point. There are a few reasons for declaring episodes as an instance method. First, the API service protocol should have a consistent interface. Later in this series, we add support for endpoints that accept parameters. We can't use a computer property if we want to pass those parameters to the API service. Using a mix of instance methods and computer properties is confusing and results in an inconsistent interface. Second, a computer property implies that the value that is returned is computed or derived. That is what a computer property returns, but that is not what happens. To fetch the list of episodes, the API client creates and sends a request to the mock API. Even though this is and should be in implementation detail private to the API client, I feel it is more appropriate to define episodes as an instance method than a computer property. This choice will make more sense as we add support for more endpoints. With the API service protocol in place, we can create a type that conforms to the protocol. Add a Swift file to the networking group and name it API-client.swift. Add an import statement for the combined framework at the top, and define a final class with name API client that conforms to the API service protocol. To conform to API service, we need to implement the episodes method. Open episodes viewModel.swift in the assistant editor on the right. We move the implementation of the fetch episodes method of episodes viewModel to the episodes method of API client, with the exception of the sync method. We fix the implementation of fetch episodes later in this episode. We need to make 3 changes to satisfy the compiler. First, remove the reference to the isFetching property of episodes viewModel. Second, wrap the publisher the receive operator returns in a type eraser by applying the erase to any publisher operator. We discuss type erasure and the erase to any publisher operator in detail in building reactive applications with Combine. Third, return the publisher the erase to any publisher operator returns from the episodes method. The API client class needs to be flexible, and hard-coding the API token and base URL isn't a good idea. Open environment.swift and define a static computer property API base URL of type URL. The static computed API base URL property returns the API's base URL. Notice that we forced and wrapped the result of the initialization, because that should never fail. We do the same for the API token. We define a static computer property API token of type string that returns the API token. Revisit API client.swift. We access the API's base URL through the environment enum and append the path of the episode's endpoint. We do the same for the API token. The view model uses an object conforming to the API service protocol to fetch the list of episodes. Open episodes viewModel.swift and declare a private, constant property API service of type API service. Notice that the view model is unaware of the existence of the API client class. This is protocol-oriented programming in action. The view model is compatible with any type that conforms to the API service protocol. This comes in useful later. The API service is injected into the view model during initialization. This simply means that the initializer accepts an argument of type API service. In the initializer, the value of the API service parameter is stored in the API service property. Now that the view model has access to an object conforming to the API service protocol, we can fix the fetch episodes method. This is simpler than you might think because the API service does the heavy lifting, not the view model. In fetch episodes, we set isFetching to true to communicate to the user the application is fetching the list of episodes. We then ask the API service to fetch the list of episodes by invoking the episodes method. The rest of the implementation of fetch episodes remains unchanged. Before we can build the application, we need to update the initialization of the episodes view model in rootView.swift. We create an instance of the API client class and pass it to the initializer of episodes view model. We also need to update the initialization of the episodes view model class in the static previews property in episodesView.swift. This is a bit of a problem because we don't want to fetch the list of episodes from the mock API every time the preview is updated. The good news is that we laid the foundation to make this problem straightforward to solve. Add a Swift file to the networking group and name it API preview client.swift. Define a struct API preview client that conforms to the API service protocol. Implementing the episodes method isn't difficult. Earlier in this series, the view model loaded the list of episodes from a JSON file included in the application bundle. We can reuse that implementation. We throw a fatal error in the else clause of the guard statement. We create an instance of the just struct passing in the array of episode object. A just instance is a publisher that emits a single element. We wrap the publisher in a type eraser by applying the erase to any publisher operator. There is one problem though. The failure type of the publisher is never, and it doesn't match the failure type of the publisher the episodes method returns. By applying the setFailureType operator, we can change the failure type of the upstream publisher. The setFailureType operator accepts the error type of the downstream publisher as an argument. In the static previews property of the episodes view preview struct, we create an instance of the API preview client and pass it to the initializer of the episodes view model class. Resume the preview to make sure we didn't break anything. Build and run the application to see the result. Nothing changed from the perspective of the user, but we laid the foundation of the networking layer. The JSON file of episodes shouldn't be included in the applications bundle because it is only used by the preview. Let's move the stubs group in the resources group to the preview content group. The networking layer is taking shape, but there is plenty of room for improvement. In the next episode, we make a number of changes that pave the way for an extensible, flexible networking layer.